So let me now introduce our first speaker. Andre was our keynote speaker, but I'd like to introduce Dr. Rory A. Cooper. Rory is with us, who has a long list of responsibilities, right? I guess that's one way to say it, Rory, right? But I'm going to read them, Rory, if you don't mind, because I think this is really, really important. Rory's the Assistant Vice Chancellor. He's also a Distinguished Professor and FISA Foundation and Paralyzed Veterans of America Professor of Rehabilitation Engineering in the Department of Rehabilitation Science and Technology. This is at the University of Pittsburgh. Rory, I also have that you're the founding director and VA Senior Research Career Scientist in the Human Research Laboratories at the University of Pittsburgh and the U.S. Department of Veterans Affairs. You have very unique perspectives on some very unique programs that NSF has. I know that a lot of these have played into your development, your career, and the things that you do. So just delighted to have you here. Let me welcome you and just pass the baton over to you right now, okay?
Great. Thank you very much, Louis, for the opportunity, for all of you, for allowing me to speak with you today. It's wonderful to represent, to be able to speak to two wonderful organizations, the National Science Foundation and the National Academies. I do have a few slides to share. Great. So I've actually had the privilege to participate in a number of NSF affiliated programs. And I think to do the work that we do and others do, sometimes it takes multiple NSF programs. So I first like to just throw out a little quote from the National Council on Disability, which is an independent agency, much like NSF, but it's focused specifically on increasing opportunities for people with disabilities in the United States. And so I like this little quote here. Basically, it's really about, another way to put it is nothing about us without us. In other words, people with disabilities should be included in all aspects of society, and especially those areas that affect them. And that I wanted to throw that because that's kind of the premise of my life's career. You probably can't see it because we're using Zoom, but I'm a U.S. Army veteran who was injured in the service and have a spinal cord injury and have used a wheelchair. And I obtained all of my degrees after becoming injured. And so I just throw out a little bit about me before I go into some of the work that we've worked on. I've included sort of two articles here that I find interesting. One is The Importance of Mentorship. That's a picture of me doing my first marathon after getting out of rehabilitation. And with me is my peer mentor, who happened to be a U.S. Marine veteran injured in the Tet Offensive in Vietnam. And Tim Davis is his name. We actually are still friends to this day. And Tim was married and worked, and it was excellent in sort of showing me what could happen. So it's not just mentors in your academic career, but there are mentors in other aspects of your life that are also important. The other article is from Engineering Times, and I happened to be doing a race. And when I finished, I was a bit dirty, and I went to a Burger King, and I ran into a reporter for Engineering Times. So they didn't know he was a reporter at the time. And 20 years later, I was just finishing the Air Force Marathon, and a gentleman ran up to me and said, "Hey, are you Dr. Cooper? Are you Dr. Cooper?" And I said, "Yes, I am." He goes, "My son just beat you in the marathon." And I said, "That's very nice." He says, I don't mean it like that. I want to give you something. And he had a copy of this article laminated. He happened to be an engineer, and his son was born with spina bifida. And he laminated two copies of the article, and hung one in his office and one in his son's bedroom. And he wanted his son to meet me in person because his son was studying engineering at the University of Michigan. And so I guess what I'm pointing out is you could be a role model even when you least expect it. So I've had a number of programs. We had the NSF Quote program at one time. This was really to allow us to study our own institution and how we were doing addressing the needs of students with disabilities in the engineering disciplines and other science fields. And the nice thing about this is that we got to work closely with our Office of Services to Students with Disabilities, which arisen out of the Rehab Act of 1973, and then later with the Americans with Disabilities Act. And most institutions have such services. Some of them have expanded up to support faculty and staff as well. And the nice thing is, to this day, the trustees report on the progress of students with disabilities on our campus. And so, from an NSF funding, and the nice thing about that is, as you are probably all well aware, university presidents or provosts talk to one another. And when they talk about our diversity initiatives, they let them know that we include veterans and people with disabilities in our diversity initiatives, and we track those numbers as well, especially graduation rates. So probably the diamond in our work has been, I've been involved with the NSF Research Experience for Undergraduates program for over 20 years. And I think this is one of the most wonderful programs that NSF has. We've had over 200 students supported by NSF, but over 1,000 undergraduates supported by various through supplements, through other foundations, through other agencies as well. As a matter of fact, we spun off 2 other programs. We were able to convince the Department of Veterans Affairs to create a similar program, which is called Valor. And that's VA laboratory experience and research, but it's much like the NSF REU, except for research within a VA laboratory. And also the Nielsen Foundation, which supports people with spinal cord injuries. And we target underrepresented students. And of course, all REUs basically target universities that don't have those research opportunities or have limited research opportunities for their undergraduate students. But let me show you, from this, it's resulted in several peer-reviewed journal publications and other documents as well, demonstrating that technology does promote social mobility, health, and participation, all very important and goals for our society. And I'm going to just show you the impact of some of our students on the real world.
It's a common summer scene: children playing in the water, splashing each other, or going down a water slide. But for some kids, like Sam, water is an obstacle. How do you build a water park that all kids can enjoy? That's the question Gordon Hartman had. He runs the world's first accessible theme park, Morgan's Wonderland in San Antonio.
We had to come up with a wheelchair that would allow for it to get wet and still be able to move about through the use of someone's ability to use a joystick.
That's when he discovered the work of Dr. Rory Cooper.
It could revolutionize the wheelchair industry.
Brandon Davler, a current graduate student at Pitt School of Health and Rehabilitation Sciences, is a researcher studying under Rory Cooper. Their team works out of the Human Engineering Research Laboratories, where they modeled and built the new chair. The chair that makes a challenging trip to the water park, well, fun.
I like to have the freedom to run around.
It was rewarding to see just how he lit up and the enjoyment that he got out of going through the sprinklers and the water.
He wants to be independent. Quite frankly, we let him go for 30 minutes by himself, and that's what he wants.
And Rory thinks children without disabilities who witness this independence will be influenced too.
That's the kind of experiences you want kids to have, so that when they grow up, they don't have those biases, and they can say, "Hey, I've seen people with disabilities do it just like I have."
And one of the things, you have graduate students and undergraduate students all working together to allow, places like SAM to use those chairs. And they learned about that design, development, fabrication, as well as patenting and publishing several papers on this topic, but also just the real world impact. The elevators are a program that's it's really cool. We were part of the initial class. It was nice to hear about of I-Core for Learning, and it's helped to replicate this program across the United States, as well as also allowed us to have an NSF RET, research experience for teachers, teaching, because in the field of STEM, many kids with disabilities stop studying STEM after middle school. So we really need to reach out to the teachers in order to encourage them to stay in STEM fields and take science and technology classes so that they can go on to study engineering or science and technology later on in life. And so the Elevate program is much like the REU program, except it's targeting both undergraduates and graduates who are veterans, primarily wounded or injured or ill veterans. And we've had a pretty amazing success with this as well. And two things, actually changed the GI Bill. If you are familiar with that, post 9/11 GI Bill was extended in order to give 5 years instead of the normal 4 years of support, or 48 months rather than 36 months. And working with the Student Veterans of America, and it's also exciting that several of the alumni for our program have become leaders in the Student Veterans of America, which is one of the largest post 9/11 veterans organizations. And this is just some of the quote, but let me show you in their own words. Well, we also wound up publishing 2 books. Matter of fact, I'm here to meet with some of the senior leadership of the military at the Warrior Games today, and that to help change DoD policies. So we did one on warrior transition leadership and also promoting successful integration, as well as we've published several peer-reviewed journal publications on the topic.
I tell people frequently, and I really mean this, is kind of like Willy Wonka in the Chocolate Factory. I get to play with robots and all these technologies.
Our mission is to apply engineering and advanced technology to improve the mobility and function of individuals with disabilities. A large number of them are our veteran population.
Every day that you come in, there's this kind of wonderful energy here.
From students to staff to faculty, we wouldn't really be living up to our mission if we didn't include people with disabilities in all aspects of what we do. Our vision is a world where everyone with a disability can participate on a level playing field to their greatest extent possible.
I've got a disability, I certainly wouldn't think of myself as disabled, but it was having a huge impact on my life, on my wife, and my children. We can do better than that. We have to do better than that. So I work here because I want to give everyone an equal opportunity to whatever they want. Disability shouldn't be the thing that prevents them from getting those things.
Then we learned that some people we got involved in the ATE program, the NSF Stanford Advanced Technology Education Program, and working with the Hiram G. Andrews Center from the Commonwealth Technical Institute, which it's one of the only community colleges in Pennsylvania that is tailored to students with disabilities. It is a fully accessible campus with medical support, non-medical assistance support, fully accessible dorms, very remarkable. And our goal was to make advanced manufacturing inclusive so that people with disabilities and others could work and everybody else could work side by side. And we are still part of the ATE program with the University of Wisconsin-Madison through the Access ATE. So we're expanding that to provide resources to community college technician education across the United States. And also just want you to know, one of the really challenges here is that laboratories and field works and computing are sort of the three barriers to people with disabilities, as well as teacher or professor education. And but from the technical side, this is an interesting picture here. This was one of our ATE projects. We developed a patent and a prosthetic hook compatible mouse. So we have in this picture is Dave is a Coast Guard veteran who lost all 4 limbs doing a rescue in Alaska, saving other people's lives. Happened to be a computer scientist as well and wanted to return to work. And we created a technology that allowed Dave to do that, as well as also, interestingly enough, instead of using a head tracking or eye tracking system, which was a very expensive solution on the order of like $7,000, we were able to solve this problem for about $40. Other colleagues could use this computer as well. We were part of the ERC family. It was great to listen to the session prior to this and the lessons of the ERC. We were the Quality ERC, and what's great is we've got some of our alumni in various industries as well as in academia and in governments, helping to change that. I think the big thing was teaching this, doing some things that Lynn Preston, as we heard about earlier, pushed us to do, like powerful robots and interaction with humans, soft robotics, incorporating social scientists with engineers were all things I think we contributed to as part of our Quality ERC, among other things. Just give you a little bit of an example of some of the Qualt work.
My research project is focused on the performance evaluation and the user interface of the assistive robotic manipulators. So the assistive robotic arms is that a robotic arm can be mounted on the wheelchairs, and that can assist wheelchair users or people with a disability to do some daily tasks using the control interface. So the reason we developed the interface is that we have tested with current robotic original interfaces, and a lot of users have difficulty learning those, either memorize the keys or memorize the command or combination of different keystrokes. So the interface we developed kind of reduce those frustration, so they can quickly learn how to control the robot, and they can do the task just within 10 minutes. There was one veteran look at our robot, and he was so excited, and he said he just pointed to the robot and saying to the caregiver, "That's what I want." So I think the robot would be really helpful for people sitting in a chair and still want to achieve something.
So it's really exciting that Dr. Chung was a student in one of our ERC and now is a faculty member, and just to give you that exciting about that work. And we took a task that people would take hours to days to learn, minutes to perform, and really took it minutes to learn and seconds to perform. We had that good fortune of having an IGERT for a long time, almost 15 years. Wonderful program, now somewhat replaced by the NRT. This allowed us to train engineers to have some develop clinical skills as well, or social science skills, to basically become better engineers and more engaged engineers. And it was very attractive to students with disabilities, but most importantly was creating cohorts of students with and without disabilities working together as the next generation scientists and faculty members, or engineering scientists and faculty members. So we exposed them to the engineers to clinical science fields like physical therapy, occupational therapy, orthotics, prosthetics, and even cognitive science to some degree. Partnership between Carnegie Mellon University and University of Pittsburgh, if you know that we have overlapping campuses. and working closely with also local organizations such as Paralyzed Veterans America, United Cerebral Palsy, and Independent Living Centers, Easter Seals. And this is just some examples of some of the projects that the students worked on. It's so, Mark here worked on the strong arm, which was, a powerful robot working in close proximity to transfer. Mark went on to go to be a professor at Stanford University and then started his own company, like many young faculty or young PhDs do nowadays. The other picture with our MeBot robot that started as an ERC project and then continued with the IGERT, but I love that picture because it's got an REU student. The young lady's an REU student, Dr. Kagiati. It was an IGERT student, and Dr. Kim is a former ERC student and a professor at Yonsei University. So kind of all generations in one picture showing the technology. And you can see climbing using complex robotics and machine learning and machine vision, all with human. And Dr. Kim, if you look carefully, you'll see he himself has a very high level spinal cord injury and limited use of his hands. I probably has a little more faith in the technology than I would, given to a graduate student or undergraduate student working on it. You can see he lets go and shakes his hand there a little bit as he talks. And you could go up and down. This is a very large curve, so that's one of the big barriers in society. So I'd like to say thank you for this opportunity, and I'm looking forward to the discussion later.
Rory, thank you. Thank you very much. To say that that's inspiring is almost an understatement. And I guess, it'd be hard pressed to find a more direct example of societal impact, Rory. I mean, what this has meant to your life, right, and to your career, to be able to have that, not a continuum of support, but this variety. That photograph that you showed in the last video where you said you had an REU, you had an IGERT, you had an ERS, they were all sort of encapsulated there. And so the impact on the individuals that are involved in your work, absolutely. Do you see this scaling in some way? How is this happening nationwide? What is your sense?
I think it's scaling in several ways. If you think about all the students that participate in the REU, they are out at other universities across the United States, changing their culture. And of course, the IGERT students are either in government, industry, or academia, changing culture as well, are the NSF students. So the ERC students you saw there, we have former students that are helping to make Google software accessible. They're making Microsoft software accessible. As a matter of fact, some of the former students from our ERC are at Microsoft and others are at the University of Washington. They formed a joint center together, the Create Center. One of our former ERC students is at Amazon, and he made sure that the Kindle was accessible. So I can see, and as I mentioned, that the VA has replicated this program. Well, there are several of our former NSF students that are now in VA leadership, and so they are changing VA policy in that regard as well. So I do think, and then now, as a matter of fact, last night, I'm here actually in Orlando for the Warrior Games, which is our Department of Defense reintegrations through sports program. And I met a guy named Captain Avila who was severely wounded in Iraq. And, his wheelchair was fitted by my wife and I, but it was designed by a company by former students of ours.
So full circle, right? So, Rory, I know you told me that you may come in later, audio if you can. There's some other things, I'm sure we'd want to bring up in our discussion session, but I'm going to move on now to stay on time, but thank you so much again for sharing your story with us. Thank you very much, Rory.
Thank you. Thank you for the opportunity.